Hello, my name is Keith Glennon. I'm a postdoc in Okinawa at OIST, and I'm going to be talking about K27 symmetry of the closed bosonic string and branes. Basically, the argument is that the low energy effective action of the closed bosonic string in 26 dimensions possesses a symmetry which is generated by this Kac-Moody algebra K27. Okay, so what is the background to this poster? The background is the E11 program and M theory. So basically, E11 program says that 11-dimensional supergravity, which is the low energy effective action of M theory, dimensionally reduced, for example, down to 4 dimensions, one finds that the Kaluza-Klein scalars that arise can be modeled as a coset model based on this exceptional symmetry group E7, as long as we quotient out this Cartan involution invariant subgroup of E7, which turns out to be SU8 in that case. It's just an accidental discovery decades ago. Same thing happens when you go to 3 dimensions, one finds E8. There's a lot of evidence that when you, and similar dimensions, there's a lot of evidence when you go to 2 and 1 dimensions, one finds an E9 and an E10. So the question was, if you go to 0 dimensions, E11, does it make sense? Well, my advisor, Professor Peter West, in 2001 conjectured that the initial 11-dimensional theory arises as the nonlinear realization of E11 with its vector representation semi-direct product, where we quotient out this ICE11 subgroup, generalizing the subgroups in the table. Okay, and it turns out that this structure in equation 2 is very similar to the Volbein formulation of general relativity, which is based on GL11, semi-direct product with its vector representation, which are the translations, and we quotient out this IC GL11 subgroup, which is the local Lorentz group. So you see, it's a massive generalization of the Volbein program, but we never invoke diffeomorphisms, at least directly. And the claim is that you'll still find the structure of general relativity. Okay, so we're going to apply the same kind of thinking to K27, to the closed bosonic string. It was discovered by studying it directly that this Kac-Moody algebra K27 would describe the dynamics of the closed bosonic string. And that's what we showed in this recent paper, okay? So there's a well-defined way to show that the algebra should be as in 5 and 6. And the fields that arise at K27, you see the first one is a HAB, turns out to describe the graviton. Second one is a field describing the dilaton. Third one is a Cabral-Monde, which you'd predict. So what about these other ones? Well, it turns out we can interpret them as duals to those fields. At least most of them we can interpret as duals. Maybe not all of them. That's a separate question. There's meaning for that in E11 when they don't have a direct dual, etc. This 22 form turns out to be the dual Cabral-Monde. 24 turns out to be the dual scalar, and the 23,1 describes the dual graviton. So we're finding a first order formulation of physics where duality relations are manifest, and you'll see this here in equations 18. We're going to find first order duality relations between the scalar and the dual scalar, and we're going to find all of this structure here shows that it's consistent to impose these duality relations as actual duality relations. And the whole idea is we're going to go from these duality relations in a well-defined manner, projecting out one of the two equations using derivatives. We're going to find in equations 22 to 24, we're going to find the equations of the closed bosonic string. So most of this poster is just arguing that it's consistent to impose equations 18 as duality relations between, say, the scalar and the dual scalar. When you work out the structure of coset models, etc., we're going to find a generalized Volbein, where you see directly this is a generalization of the Volbein program of general relativity, generalized covariant derivatives, transformation rules on all these derivatives. It all has to be consistent following the logic of coset models. We're going to find the equations of motion of closed bosonic string. So any more questions, ask me at the conference. Thank you very much for your attention.